Welcome back. In this session, we are going to describe how to find conjugate harmonic function when we only have one of the two pairs. So given, find the analytic function f of z given by u plus iv if u is given by e raised power x into x cos of y minus y sine of y this is a problem. So here the question is as good as asking you to find the conjugate harmonic of u, and once you have found, then you write u plus iv. So solution, f of z equals to u plus iv is analytic if and only if u and v satisfies the Cauchy-Riemann's equations, i.e. partial u partial x equals to partial v partial y, and partial u partial y is minus partial v partial x. So these are the CRE. Now you see our u is nothing but x e raised power x plus y minus y e raised power x sine y. This is our u. So it tells us that partial u partial x will be given by, so if I let, just right here, so partial u partial x, so this one to be u, this one to be v, so u prime is 1 times v, I get e raised power x cos of y. V prime is e raised power x cos y, then I multiply by this, I have plus x e raised power x cos y. And then minus, here I only have e raised power x, so that is just y e raised power x sine of y. And partial u partial y, here only y is cos, so derivative of cosine is negative sine. I'll have negative x e raised power x sine of y. Here I use product rule and let u to be my y to be u, and then this other part to be v. So u prime is 1, so I get just minus sign, and then I have e raised power x sine y. If I get this one, I get cos, and then the plus y e raised power x cosine of y. So that now, from the Cauchy-Riemann equations relationships, I can define now my partial v partial y and partial v partial x. So that means that partial v partial x, which is the same thing as saying negative of partial u partial y. So negating this one, I get x e raised power x sine of y plus e raised power x sine of y plus y e raised power x cos of y. All this one equation 1. And then partial b partial y, you get the same as partial u partial x, which will be partial b partial y is e raised power x cos of y plus x e raised power x cos y minus y e raised power x sin y. All this one equation 2. From calculus, we know that dv is partial b partial x dx plus partial v partial y dy. So we should be dv equals to, just replace x e raised power x sin y plus e raised power x sin y plus y e raised power x cos y, and then dx plus partial v partial y is e raised power x cos y plus x e raised power x cos y minus y e raised power x sin y, and then dy. So let's call this one equation 3. Now to get b, we just integrate both sides of equation 3. So integrate both sides of equation 3. So we'll have integral of dv. Now the integral of x e raised power x sin y plus e raised power x sin y plus y e raised power x cos y dx plus integral e raised power x cosine of y plus x e raised power x cosine of y minus y e raised power x sine of y dy. So integrate term by term. So integration of dv is b. This with respect to x. So actually I can say sine of y, because that doesn't depend on x. Integrate x e raised power x dx plus this with respect to x, when integrate e raised power x, just e raised power x. So we'll just have sine of y times e raised power x. And then this other part here, cos y and cos y, they don't depend on x. So just have y e raised power x cos of y. A constant of integration will add at the last step. Plus, this is with respect to y. Integrating cosine function, you get a negative, you get a positive sign. Yeah, so there's be just e raised power. Integration of cosine is positive sign. So e raised power x sine y. Here, integration of cos is also positive sign. So x e raised power x sine of y. Here, this y and sine y. So we factor out e raised power x. We integrate y sine of y dy. Now you see this process or that step, this term. Okay, we don't cancel, so there are two of them. So they just don't cross some step. So this is e raised power e x. Those two terms do not cross because they have the same sign. So e plus e raised power x sine of y. So let's use integration by parts quickly to integrate this part. So x e raised power x dx. If we let our v to be, our dv to be e raised power x dx and our u to be x, then this means du equals to dx. And here v will be e raised power x. So integral of u dv by parts is uv minus integral of v du. So integral of x e raised power x dx will be u is x, v is e raised power x minus v is e raised power x, du is dx. So integration of e raised power x is just e raised power x. So this will be the answer to this part. And let's also do the integration by parts for this other y part. So integral of y sine of y dy. So let dv to be sine y dy and v to be y. This tells us, and u to be y, that du equals to dy, and this means v equals to negative cos y. Remember, when you integrate sine, you get negative cos. So integral of y sine y dy will be uv, u is y, v is this, so negative y cos of y, minus integral of v du. So this v course has a negative sign, so it will be plus, and du is dy, so we'll have cos of y dy. So it will just be negative cosine of y. Integration of cosine is sine, positive sign. So we have this part, or this y part here, and this one for the x part here. So therefore, this means that our v will be sine of y into, where is this integral we write, x e raised power x minus e raised power x plus, so this and this will give us 2 e raised power x sine y. So I've taken care of this, and this one here, this will be plus so don't have to add those two terms. Remember, the way we work out the v or the conjugate is not like the normal integration of getting the final integral value. Terms which are common will cancel one and retain one. But meanwhile, let me just write all of them first. So plus e raised power x sine y plus y e raised power x cos of y plus e raised power x sine of y plus x e raised power x sine y minus e raised power x, and this part I write minus y cos of y plus sine of y, and then I add c to take care of all the constants in all the integrations we have been doing. So the next step now, let's open the brackets and see which terms are repeating themselves. We ignore the repetitions and then pick the unique terms. So e raised power x, so y e raised power x cosine of y. So v will be x e raised power x sine y minus e raised power x sine y plus e raised power x sine y plus y e raised power x plus y plus e raised to power x sine y plus x e raised to power x sine y minus minus is plus. Remember this x here. So we'll have plus y e raised to power x plus y minus minus plus is minus e raised to power x sine y, and then plus constant of integration c. So let's cross in those terms which are the same and have opposite signs. So this and this gives us 0. And then also this term goes to 0. And x e raised to power x sine y, x e raised to power x sine y. So you see this term and these other ones are repeating. This and this are the same, so you cross in one. Similarly, this term here, and this term here are repeating, so we cross one. So the final answer will be, remember that's usually the procedure of finding the conjugate harmonic. Terms which are alike, you ignore one and pick only one out of the two like terms. So therefore, our v of xy will be given by x e raised to power x sine y, and then plus y e raised to power x cosine of y, then plus c. So which can be factored as e raised to power x into x sine of y plus y cosine of y, and then plus c. Now that is the v function, but they wanted us to find the value of f of z, which is given by u plus iv. So therefore, our function f will be u, which was e raised to power x into x cos y minus y sine of y plus, say, I e raised to power x into x sine y plus y cosine of y, and then plus c. So y cosine of y, and then plus c. So this is the function that the question wanted us to find. So thank you.